For thousands of years, fungi have been revered for both their culinary and medicinal purposes. And now our very future and the ecology of our planet could depend on the humble mushroom. If you were one of the lucky ones who got to experience our next speaker from last year, he needs no introduction, just a drum roll. So be prepared to be shocked, awed, amazed, and excited by this phenomenal man and what he's about to share with you. And I wanted to mention, for those of you who don't know about his work, you can learn more, because I know he does not like to promote himself, by going to fungi.com. So that's a little plug for him in advance. So please join me in heartily welcoming the author of Mycelium Running, How Mushrooms Can Help Save the World, Paul Stamets.
Thank you, Carol, and it's an honor to be here again. I want to first acknowledge my wife, Dusty, who's been my partner, my love of my life, my dream come true, my comrade and co-conspirator on so many adventures in the past several years. I want to acknowledge my ancestors and my elders who have come before me. There's a lineage of knowledge that's passed downstream from elders to younger people. And as I get older, I can see how important that is. Dr. Alexander Smith and Dr. Daniel Stuntz were two of my mentors. They kind of picked me up when I was kind of like a mascot. I was 17, 18 years of age. And I hung out with these great scientists, and they inspired me. And I'm a very shy person in general. I have a stuttering habit, and so I really get fearful in front of large audiences. This audience is small, so that's probably good for me. But I want to first welcome you as Earthlings, fellow Earthlings, and also as mushroom people. Most of you may not realize that we are descended from fungi. Fungi are our ancestors. And there's breaking news. In the December issue of the Journal of Eukaryotic Microbiology, 25 scientists co-authored, which in and of itself is a big event, a new seminal article erecting a new super kingdom combining fungi and animals together. And so Animalia and fungi have been joined together in a super kingdom called Opisthokonta. Not the best name, I agree. But it speaks to the evolutionary history that we share more commonly with fungi than we do with any other kingdom. So I want to take you sort of on a magical mushroom mystery tour. And it's, we all live, as a very special lives. We are evolutionary successes. We should cheer, because we are here today through billions and billions of years of cell divisions and evolution, and we are now have achieved this status. And I oftentimes wonder if there's a United Organization of Organisms, otherwise called UH-O, and every organism on this planet had a vote. Would we be voted off the planet or on the planet? And since this conference is about sustainability, I want to speak, very specifically about how we can increase that aspect. And so I'm going to offer 4 practical solutions that can help. There'll be our paradigm shifting that can help steer this planet on a much better course. And at the end of the presentation, I'll announce a new invention that I have. I've been a little bit obsessive-compulsive about inventing, and I filed now 22 patents in the past 3 years. And I've decided that in order to create a paradigm shift, you have to steer the ship. You can be an advisor and you can tell people great ideas and try to get them to do things. But, in essence, if you don't control the intellectual property of your own ideas or that which can help other people, then you become subservient to other people's interests. And so this is why I've gone on the patent path. I'm really happy to say that I have 2 more patents. I just heard from my patent attorney. So I have another patent that's being awarded. And next week I have another patent that is coming online. So you can go to the uspto.gov homepage and look up my patents. But enough of that. Can we have the lights down further, if we could? This is where my wife and I like to go to church on Sundays. We love the old-growth forest. We live outside of Olympia, Washington. We're only a few miles from the old-growth forest, and we try to get into the old-growth forest often. In the old-growth forest are ancestral strains of fungi that exist nowhere else in the world. Understanding the value and importance of these fungi, I think, is instrumental to steering a path towards a better and brighter and healthier future. Let's see if this works. Oh, good. It didn't. Okay. So this is what I'm going to primarily be talking about is mycelium. Now, mycelium is this fine fabric of cells that decompose plant and animal matter. You all have seen it, and if you haven't seen it, just go outside and find a piece of wood and just pick it up. And underneath, you'll see this lattice matrix-like network of cells, oftentimes white, sometimes brilliantly colored, and it grows and it decomposes wood. And so what we do at our facility, and which mimics nature, is we take wood, we add mycelium, and we create soil. So these are the grand molecular disassemblers of nature. They decompose plant tissue and animal tissue, and the end consequence of which generates soil. In this process, lots of other things happen in the ecosystem. And the building of soil, as many of you know, it takes about 1,000 years to build an inch of soil. At our facility, we build soil like this in about 4 months. And understanding and the thickening of soils is directly related to biodiversity and increasing the carrying capacity of nature. The thinning of soils and loss of topsoils is exactly the opposite. Where we lose biodiversity, I believe habitats have immune systems just like people. And in order to potentiate the host defense of habitats' immune systems, and we're a reflection of the environment that's given us birth, it's very important that we invest in biodiversity. How biodiverse is indeed the planet? This is where scientists are extraordinarily excited. In the past several years, the biological sciences are going through a revolution, and they're just absolutely mesmerized and astonished by how much biodiversity there is in nature at this point in time, and unfortunately, how much we're losing. So the mushroom mycelium oftentimes looks like this. This single strand can hold 30,000 times its weight. And so when the mycelium goes through the environment, it grips it. It prevents erosion. And as it honeycombs the soil, and these microcavities form where they become water pockets and reservoirs, it becomes a water bank. And then it slowly releases water over time. So these sponge-like environments infused with mycelium, I call them myceliated habitats, end up holding moisture. And as we all know, water breeds life. And so these microcosms become universes of myriads numbers of organisms, without which the mycelium, if it's not there, is lost. Mycelium is the construct of the food chain. These are the networks that are able to move nutrients over great distances. So I spent many years as a scanning electron microscopist. I'm going to show you a few of my images. This is what the mushroom mycelium looks like under high magnification. It is only one cell wall thick, and it networks and it branches, seemingly undifferentiated. And that's why scientists for a long time, you can't identify a mushroom species by its mycelium. The mycelium will give rise to a mushroom like an apple tree gives rise to an apple. So the mushrooms are the fruit, in a sense, of this mycelial network. And so scientists thought, well, they're not differentiated, they are interesting, but we don't understand how to study them. There's been an awakening, and indeed my life has been a series of epiphanies, an increasing awakening of the importance of these mycelial membranes. They infuse all habitats, from the tundra into the deserts. Of course, a lot more diffuse in deserts because there's less organic material, but nevertheless there's fungi throughout the deserts. And the mycelial network, under the right conditions, will then coalesce. And then they form these little balls, and very, very quickly, that slide was in reverse, and a mushroom, and then it emerges. And this is the first primordial state of a mushroom forming. And then very quickly, these cells then burst. And mushrooms are so powerful, they can break through asphalt. They actually are cellular explosions that are occurring over a few days. And there's a helical polysaccharide matrix, and in this polysaccharide matrix is gorged with water. And there's a one-way gate like neural synapses. And these are neurological nets. And the more that I began to understand these membranes, of course they're sentient. When you walk through the forest and you're breaking wood, you are a catastrophe in motion. And the mycelium and the fungi, because of the diversity, are reaching behind you, trying to catch up. And so I feel it is no accident, and I deeply believe that the mycelium is Earth's natural internet, and that the invention of the computer internet is a repetition of a previously proven biologically successful evolutionary model, rewarded over time. And these type of structures that we see are specifically designed for information sharing, nutrient flow. I believe mycelium is a sentient, is an intelligent. It gave birth to us. If we are intelligent, that which gave us birth also, de facto, must be intelligent. And so the computer internet, it looks like computer neurons. This is from Hank Morden. Look like neurons, human neurons, excuse me, computer neurons. This is a astrocytic photograph by Hank Morgan. And then this is from NASA, and this is the Virgo Consortium, which is a cluster of galaxies that intergalactically are strung together with masses of matter, also forming these networks. And even going further out, this is from Scientific American, and this is the cobweb of dark matter. I'm an amateur astronomer, and it's very disconcerting to learn a few years ago that 97% of the matter in the universe you can't see. And it conforms to string theory. And so going all the way out, it has dawned on me that matter begets life. Life in its simplest forms are single cells that build chains. Chains network and divide. Pretty soon this synaptic mycelial network or this internet archetype is pervasive. This is the way of nature. We are not the only life-giving planet in the cosmos. Mathematically, it's virtually impossible. There are thousands of other Earth-like planets spread throughout the cosmos. And I believe that we'll find fungi throughout the cosmos because of this simple paradigm. So where is the largest organism in the world? Well, Dusty and I live here. And this is the Columbia River is there. And the largest organism in the world is in this location in these mountains. So I hired an airplane, and I flew there. I found it. Now, this is the largest organism in the world. This is the outline of the mycelial mat. This is the mycelial mat in eastern Oregon, 2,200 acres in size, 2,400 years old. And yet the mycelium is only 1 cell thick. The largest organism in the world is only 1 cell thick. We have 5 or 6 cell layers that protect us from infection. How do these fungi do this? It's because they're in constant biomolecular communication with their environment. They're constantly sensing, developing alliances, synergisms, symbiosis, and this is a marauding parasite. It's actually 12,000 years ago, at the end of the last ice age, around 10,000 years ago, as the glaciers receded to scrape away all the soil. And these fungi come in, and they're lenses of soil that survived, and plant communities grew up, and they died, and the fungi rotted them, the soil got a little bit thicker, the lens got a little bit larger. Over 10,000 years, we develop an old-growth forest that's growing in less than 2 feet of soil. And so understanding how these membranes work in the ecosystem, they take a long-term view, because as the organism grows and the soil thickens, the carrying capacity of the ecosystem increases. More foliage, more wildlife, more microbes, more habitat. And this is something that we need to invest in, is biodiversity and encouraging the regeneration of soils. Whoops, I don't know how this is jumping around here. Okay, so there's the mycelial mat again. Now I'm going to talk about 4 inventions that I've been involved in, that I've created. One of them was in Bellingham, Washington. There was a contamination of soil from diesel spills and from trucks and buses stored over 50 years. The Department of Transportation was finding the Department of Ecology was levying fines against the Department of Transportation because they had a toxic waste site. This site is lifeless. It is full of toxins. Plants will not grow there. There's no worms. And so the Battelle Laboratories, who I've been working with in the previous 3 years, we went up there and we inoculated the soil with mushroom mycelium. There was 3 other piles. One was a control, one was treated with bacteria, one was treated with chemicals. 4 weeks later, they came back to discover see if there's been any change. This is stinky hydrocarbon, oil, gasoline saturated soil. Just 20,000 parts per million of the of these hydrocarbons. The mycelium, which is here, absorbs the oil like a sponge. And then, as the oil is absorbed, the mycelium, it produces these extracellular metabolites, sweat. They're huge capillaries for water. Mycelium can move water over great distances. And as it exudes these extracellular enzymes that break carbon-hydrogen bonds, which is the basis of hydrocarbons. So we came back between weeks 4 and 5. The first tarp was pulled back as a control pile. It was stinky, dead, and neutral. No life. Stunk like oil. Second pile with bacteria. Same story. Third pile with the chemical treatment. Same story. And then we came to our pile. It was covered with hundreds of pounds of oyster mushrooms. Some of these oyster mushrooms were 12 to 16 inches in diameter. Any of you know oyster mushrooms? These are very happy oyster mushrooms. These are very, very large mushrooms. So the soil was analyzed subsequently, and 20,000 parts per million of these hydrocarbons were reduced to less than 200 in 6 weeks. The mushrooms sporulated, and they attract insects, and insects laid eggs, and then something else occurred, is that then plant communities returned. Now, birds came in. They were going after the developing larvae. They brought in seeds. There were also windblown seeds. But then our pile became an oasis of life. And it really underscored my present philosophy in my new book, that these fungi are healers. They're environmental healers. They come into these ecosystems and they condition it for other life forms. So the fungi, the mushrooms rotted, bacteria took over. So bacterial remediation occurred. Plants came in, phytoremediation occurred. So I think these are keystone organisms that